Okay, ladies and gentle people, let us start cabbages with this one. Okay. Everybody give me on the first graph here, I want an x-intercept. My x-intercept equals -5, and my y-intercept equals +3. Graph it. Everybody good? Okay. Now, graph another line. My x-intercept is +5, and my y-intercept is -3. Everyone agree? Okay. Those two lines are parallel. Why? Because all I did was slide it along here, yeah? If I take this black line and I slide... Oh, son of a bee.
Son of a witch. Son of a bitch.
I actually know a guy named Mitch. He doesn't appreciate that. It's like those ads on the radio. Have you heard those for the employee of the month? And all the rest of the employees are named Dave.
Oh, yeah.
Have you heard those ads?
Yeah.
My buddy's named Dave. He's on Facebook. I hate these ads.
Son of a gun.
All right. If I take that and I slide it along there, you see that it makes the exact same line, yeah? It's quite visible.
Yeah.
Okay. Now, what does that tell us? They're parallel. And what does that tell us about their slopes? Their slopes are the same. Now listen to me. For some reason, this causes trouble. So, they're parallel. Parallel lines have the same slope. Now, guys, everybody is okay with this. Everybody gets that. Yeah, of course, if parallel, they'll have the same slope because they will have the exact same rise and run, so they could never cross. Everybody understand? But for some reason, you're at least being quiet this time. Now I'm waiting for Ekdeep and Yash to finish. No, you're not. If you were sorry, you wouldn't do it. Okay, so everybody gets this half of the point, that if they're parallel, they're going to have the same slope. The thing that for some reason is lost on kids when I teach them this is the other way around. If you have two slopes that are the same, what do you have? No. Parallel lines. All of you get this part, but if I tell you line 1, the m of line 1 equals 3/5, and the m of line 2 equals 6/10. What can you tell me about those lines? Most of you, at least once, will not recognize that those are parallel because I've only given you the slopes. I don't want you guys to fall into that trap. Recognize that parallel lines have the same slope. Any lines with the same slope are parallel. Please understand they're two sides of the same coin. Everybody cool? Okay. Parallel ones are easy. They only take 2 seconds. That's why I do it that way. Now we're going to draw perpendicular lines. Now, this takes 2 steps to prove it properly. I know all of you already know this, or a great many of you know this, but I'm still going to show you anyway. On the left side of your graph, over here, draw this line. X equals -5. How do you draw that line? You go -5 to left, 1, 2, 3, 4, 5. And what kind of line do you draw there? A vertical line right there, yes? Everybody good? Then draw the line y equals positive 5. How do you draw that? 5 up. And you draw what kind of line there? Horizontal. Is everybody cool with that? Yeah? Okay. What is the slope? I'm going to call this guy line 1, and I'm going to call this guy line 2. What is the slope of line 1? Slope is always rise over run. So what's the rise over run for line 1? How far does line 1 go up and down? Infinity, right? It goes up and down infinity. How far does it go side to side? 0. Is that allowed? No, because we can't divide by 0. So this is an undefined slope, right? And it's undefined because it is something over 0. Is everybody cool? Okay. What is the slope of line 2? What's its rise? 0. What's its run? Infinity. 0 divided by infinity is 0. So that's a 0 slope. But please notice the infinity and the 0 and the infinity and the 0 did what? Switched places. That's a reciprocal. Is everybody cool? Can everybody see that here? Excellent. Now, on the right side of your graph, draw this line. Line 4 has an x-intercept of 0, and it goes through 5, 3. So x-intercept is 0, and we go out 1, 2, 3, 4, 5, and up 1, 2, 3. Is everybody cool with that? And there's the line. Is everybody good? Yes? Okay. What is the m of line? That should have been line 3. Sorry, guys, I'm an idiot. What is the m of line 3? What is the slope of line 3? It's always rise over run. So it's up 3, and we run 5. Yes? Everybody cool? Yes? Okay. Line 4, which I'm going to draw green, line 4 has a y-intercept of 5 and an x-intercept of 3. Draw that one. What is that guy's slope? How do I get from there to there? 5 down, so that's negative 5 over 3. Is everybody cool with that? Yeah? Y-intercept of 5, x-intercept of 3. So I went down 3, or 5, which is negative 5, and that way, which is negative, or positive 3. Do you get it, David?
Yeah.
You say that very questioningly. Do you get it or don't you?
Yes, I do.
Okay. All right, is everybody cool with that? Everybody cool? All right, now, this right here, and normally I would get all of you guys, because you would be in my math class at Abbey Senior, you'd all have a protractor in front of you because I give them out to all my kids. You would measure that angle, and you would find that it was 90 degrees. Okay? Now, 90 degrees means perpendicular. Okay? Now, that is 90, right? What is this angle right here? Also 90, because it's up and down and horizontal, right? So we know that any lines, when these lines meet at 90 degrees, we have to flip the fraction, don't we? Right? Because we flipped the infinity and the zero. Everybody agrees, right? You proved it, we agree, yeah? So we now know, because if it happens once in math, how often does it happen? Always. So we now know if two lines meet at 90 degrees, their slopes are reciprocals, yes? Yeah? What else happens? Here's two lines meeting at 90 degrees. So we know their slopes have to be reciprocals, but also one slope has to be what? Negative. And this proves the point. Is everybody cool? All right. Parallel lines are really easy. Parallel lines have the same slope. Now, that's a real simple concept, yes? But let me remind you of all that means. That means the m of line 1 equals the m of line 2. So if you're in slope-intercept form and the m's are the same, they're parallel, okay? It also means the rise of line 1 over the run of line 1 equals the rise of line 2 over the run of line 2. So if there's a fraction involved and those fractions are the same, they're parallel. Everybody good? All right.
Can you repeat that again?
What part, David?
Which one? Which part? Just the rise line one.
Well, do you understand that slope is rise over run?
Yeah.
So if I find the rise over run of line 1, and I find another rise over run of some other line that is the same, then those two lines are parallel.
Oh, they have to be exact. Same.
Yes. Now, that leads to this one. X over y, y over x, because y's go above x, right? Rise over run. Remember, if those are multiplied by anything, they're still parallel, right? So y times a, any other number, over x times that same number, do I still have parallel lines? Yes. And this is the 3 over 2 equals 6 over 4 situation. Is everybody good with parallel? All right. Now, perpendicular lines have, and I'm going to write this in big capital red letters, negative reciprocal slopes. Okay? That means that you must do two things. One, and I change colors there. One, the sign changes. So if you have a positive slope, the perpendicular slope will be negative. If you have a negative slope, the perpendicular slope will be positive. The sign changes, and number 2, the rise and the run change. So, the m of line 1 is perpendicular, that's what this symbol means, to the m of line 2 if it looks like this. Line 1 is y2 minus y1 over x2 minus x1. That's how I would find line 1 slope in green, yes? So the perpendicular line, which is line 2, would be, I changed the sign. This has a positive, yes? So what would this guy's sign be? Negative, not equals, perpendicular. This side would be negative, and where would the x be? On the top, x2 minus x1 over y2 minus y1. They switch places, and that is what makes them perpendicular, which we proved with this drawing. Is everybody good? Sydney. You will always flip the fraction and change the sign. Now listen to me. This is pretty conceptually easy, yes? Right? As Sydney just said, if they're perpendicular, we just turn the fraction over and change the sign? Yes, that's all you do. Listen to me though. You are going to stop paying attention because of how easy that is. When we do the work for this, you need to pay attention because it is a very detail-oriented section, right? Let's do a couple of practice runs that we don't even have to think about to check it out.
So, quick question.
Yes,
You
Dave.
change the signs, right?
Uh-huh.
For the change signs, you put a negative instead of the bracket. That just means you're gonna change it, right?
That just means that if I started positive, the perpendicular is negative. If I start negative, the perpendicular is positive. All right, let's look at this first one. The slope is 2/3. So what will happen if I go perpendicular? We'll come back to it. All right. So if this is my slope, positive 2/3, then a perpendicular slope is what? Negative?
Negative 3/2.
3/2. Excellent. All right. If my slope is -7, then perpendicular is
1/7.
positive 1/7. Change the sign, flip the fraction. If it's 4 and it's parallel,
Negative 1/4.
no. 4.
Four.
-5/11 and it's perpendicular,
Negative 11/5.
no. 11/5. Change the sign and flip it.
Whenever you flip a negative fraction to the bottom, I flip it.
If it's 0, what's perpendicular?
It's undefined.
Undefined. And if it's undefined, what's perpendicular? 0. All right. Now, none of this changes what we do with actual equations. So we turn the page over to 192. Now, we have to decide if ST is parallel, perpendicular, or neither to AB. What decides on parallel, perpendicular, or neither? Is it the points on the lines? Is it their slopes? Is it what color we graph them with? What do we need to check for parallel or perpendicular or neither? Slope. So I got to check the slope, the M of ST, and I got to check the M of AB. If they're parallel, what will I find? That they're equal. If they're perpendicular, what will I find? Opposite flipped fractions. If they're neither, what will I find? No. Different slopes for different folks. Anyway. So, what is the slope of ST? Which are the points that are in ST? -4, -1, and -1 and 5. So I check that slope. Simran, does it matter how I check that slope? As long as I make y2 stay with x2, right? So I'm going to go 5 minus -1 over. Now what has to be first for the x's? -1 minus -4. What is 5 minus -1? 6. Over. What is -1 minus -4?
Negative 5. Positive 5.
3.
Positive 4. Negative 3. 4. Positive 3. Plus 2 over 1, right?
What's this one? No. Negative 1 minus 1 over 5 minus 1, which is negative 2 over, which is negative 1 half. What are those? That means these are perpendicular. Why? Because the first slope was 2 over 1, and that is perpendicular to the second slope.
Not responding.
As always, David, quality technology is key to delivering a good program.
Same.
Perpendicular to negative 1 over 2. Because they reciprocate and the sign changed. Does everybody understand? Ekti. Whenever, what?
Every time there's a negative on the top rate, it's going to be a rate. What? Like, you don't even flip the fraction rate.
I didn't flip any fractions, Ekti. I found the second fraction, and I found it to be a negative reciprocal of the first one, which means that the two lines are perpendicular. Okay. Now, next question. I've been given a triangle, right? If it's a right triangle, what does that tell me about one of the angles in the triangle? One of them has to be 90, which means I technically would need to check 6 slopes, wouldn't I? Right? That's a lot of work. Can I make it any easier on myself? What if I suggested every time we have to deal with anything and it's complicated? No. I don't want to check 6 slopes. Nope.
Simplify.
Well, simplify would mean I would want to check less slopes, wouldn't I? What are all of those? What are they? Points on a graph. So if I graph this, negative 3, 1. 1, 2, 3, up 1. There's A. Agreed? Where's B? 1, 2, 3, 4, 5, 6, and down 1, 2. There's B. Agreed? Where's C? 1, 2, 3, up 1, 2, 3, 4. There's C, correct? There's my triangle, yes? Which is the only possible 90 degree? C. So do I need to check all 6? I only need to check there, don't I? And that is the slope of which line? What are the 2 slopes I have to check? A and C. And what's the other slope I have to check? B and C. Now, if it's a right triangle, then what will I notice about their slopes, Ekdeep? No, slopes can't be 90 degrees. No. If it's a right triangle, what do I know about their slopes? They're perpendicular. So what do I know about their slopes? What does that tell me about their slopes, Ekdeep? That they're negative reciprocals of each other. So, how do I find the slope of AC? How do I find every slope? 4 minus 1 over 3 minus 3. So what is that answer? What's 4 minus 1? 3. What's 3 minus 3? 6. What's that? 1/2. All right, now, stop for a second. And it's going to seem like I'm picking on them, but I'm not. Heck deep. If I know this slope is 1/2, if this is a right angle triangle, then what will this slope have to be? What happens to a slope if it's going perpendicular? Look back 1 second ago in your notes. What happens to perpendicular slopes? Okay. Then don't talk to Yash and pay very close attention because it's the 75th time I've said it. Okay? Somebody help us out. What happens to this slope if it's perpendicular? Amrit. It will be -2 over 1 because you change the sign from positive 1/2 and you reciprocate it to 2 over 1. Are you good? Are you good now? Yes? Okay. So I have to check and see if this is -2 over 1. So I got to check. What do I do? Now I'm working with B and C. So it's 4 minus -2. Does everybody understand what I did there? Great. Over what? 3 minus 6. What's 4 minus -2? 6. What's 3 minus 6? -3. What's 6 divided by -3? -2, right? Which is 2 over 1, yeah? Are they negative reciprocals? Yes. So is this a right angle triangle? Yes. If this was any other number, is this a right angle triangle? No. Any other number. Does everybody understand? Okay? If you have a negative reciprocal, which means the fraction is turned over and the sign has changed, you have perpendicular lines. Okay? In slope only. Everybody gets it? All right, let's try and see. I have a line. In this first example, AB is parallel to CD. So what does that mean for slopes if they're parallel? They're the same. So the slope of AB would have to do what to the slope of CD? They would have to be equal, wouldn't they? Okay, how do I find the slope of AB? 10 minus 5 over 7 minus 3. And if they're parallel, that would have to equal what is the slope of CD? No. What is the slope of CD? A minus 2 over 1 minus 0, which is 1. Now, simplify. What's 10 minus 5? 5 over 4 would have to equal A minus 2, correct? How do I solve that? Cross multiply. 4A minus 8 equals 5 times 1, which is what? 5. Solve that. What does it mean to solve that? It means, what does it mean to solve this? Pardon me? Plus 8, you're doing the steps. You didn't answer the question, but that's okay. 4A equals 13. Now what? Divide by 4, so A equals 13 over 4, which is 3 1/4, which is 3.25. Does everybody understand parallel? Yes. All of that is correct. All of that gets you the same marks. Is everybody cool with the parallel one? Okay. Now, what if they are perpendicular? If they are perpendicular, then it is the m of AB. If that is perpendicular to the m of CD, do I change my first slope? No. It is still 10 minus 5 over 7 minus 3, correct? But if they're perpendicular, what happens to the other slope? It was a minus 2 over 1, yes? But if it's perpendicular, then what happens to it? It becomes 1 over a minus 2, but what have I forgotten? The negative sign. Where is the easiest place to put that negative sign? I'm going to wait and see if my screen actually writes. There we go. Where should I put that negative sign? I usually put it with the numerator. That's where I find it easiest to be. Am I you? So do you have to put it with the numerator? No. You can put it wherever you want. But I'm telling you, it's often easiest to put it with the numerator. Okay, there's a reason I do things the way I do them. So I'm going to put that there. Now, does anything change? What's my job? Simplify to get what? Don't tell me what we're doing. What's my goal? What's my end game, Amrit? Whenever I see something that looks like that in math, what's your final answer going to look like? A equals something, yes? So I have to do algebra to get A by itself. So now let's start simplifying. We know this side is 5 over 4, yes? Yes, David.
Since it's perpendicular, shouldn't AB also be other way around? Or would it be the same 5 over 4?
We didn't change the first one. We're checking if this one is. We have a slope, and we want to know what the perpendicular slope is, right? In the first one, we had a slope. It was 5 over 4. We were checking for a parallel. 5 over 4 hasn't changed. Now we're looking for a perpendicular. So the 5 over 4 stays the same.
Okay.
All right? So now, what is 4 times negative 1? Negative 4 equals, what's 5 times A? 5A minus 5 times 2? 10. Now, how do I solve that? Plus 10 to both sides. Amrit, think before you answer. Yes. 6 equals 5A. And the last step? So A equals 6 over 5. Now, have you done the work? Do you have the right answer? Yes. If it's a multiple choice test and that answer isn't there, do you say to yourself, self, I must be wrong? Or do you say to yourself, self, Myers is being a dick and he's trying to trick us and the right answer's there anyway? Which is it? It's the second one. 6 over 5 is the right answer. But we can write it. We can write it in how many ways?
1.2.
It could be 1.2. It could be 1 1/5. If I'm really mean, it could be 12/10. If I'm really mean, it could be 30/25. Would I do all of that? No. Of course not. One of these is the most likely answer. Would I be willing to do this? A, B, C, D. All of the above. Could I do that?
Yeah.
I could, couldn't I? That depends. I make the test the day before I write, before you get them. Am I in a good mood? Then you get the easy one. Am I in a bad mood? It's not that hard. Is everybody good? Okay, now listen. 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 I know that you have felt picked on today. Yes, you. And I know that you have felt picked on today. For math stuff. It is because you know what you are doing, but you are rushing through stuff. Slow down and think, and you know what you're doing. Every single one of you. Okay? I know it's hard to slow down and think when we're in this compressed time frame, but you must understand, over the course of the whole 3-4 weeks, we're very fast. But each concept we can slow down and think about. Okay? All right, now listen. Listen. If you take nothing else from today, take this. M of line 1 equals the M of line 2 in all its forms. That's parallel. If the M of line 1 is perpendicular to the M of line 2, that means that rise over run of the first one would have to be the run over the rise with a negative for the second one. Here's what else it could mean. It could mean this. If the first one is y2 minus y1 over x2 minus x1, then the second one would be what? X2 minus x1 over y2 minus y1, and what would have to be out in front? A negative. Does this help? If it doesn't, what should you do? Ignore it, because you already know it. If it helps you, use it. Okay? Is everybody good? All right. Now,